Hello. So we are in the guts of C++ now, week number 3. And I want to talk about a couple of pitfalls that I've seen repeat themselves throughout the class in the past week. So this is a code roundup of sorts. And it's dangerous that you can fall into with the two different types of ways of declaring objects. So either statically as an object value or dynamically as an object reference. So there's ways to mess this up and you will get into trouble. So let's talk about one of these ways. Now what I've done is I've made kind of a silly little class just to demonstrate. It's a class that's just some kind of wrapper around two ints. In the constructor you pass along the two ints, you set them, and then you can return them with these getters here. Okay, so the first pitfall that I've seen is somebody may declare an object as such. Let's say my class, object1. And so this is going to be a true object value, not a reference. I'll just pass two numbers along. So 174 and 476, my two classes. Okay. So this is all well and good. So I'll just compile real quick. And actually, let me call this method pitfall1. I'm sort of quarantining each pitfall in its own method here. I'll call pitfall1 from the main. So, okay, so that did nothing actually. So anyway, so the sort of thing that I've seen people do is they will then declare a reference to this object. So there we go, so we get the address. And then they'll do some stuff, ... And eventually, so they have this reference and they go to delete it. Okay. So fine, I mean, I have a pointer to some address in memory. I'm saying I want you to free up that memory. Compiles just fine. So let's see what happens. Boom! Abort. Core dumped. Okay. That sounds pretty bad. So what's happening actually is you should not be deleting an object that is on the so-called stack. So this is a local variable to this method pitfall. All the variables that are declared in method scope get deleted at the end of the method. So they're already going to be deleted for you. If you try to delete them yourself, that is an invalid operation. You should only be deleting dynamic memory that you yourself have created. So if I instead did something like this, where I dynamically initialized a variable, an object with those properties, then I could delete it, okay? So this should not crash anymore. But there's a problem. If I try to remove a variable that doesn't belong to dynamic memory. This does not belong to dynamic memory. This belongs to local memory for this method, which again is called static memory. And it's on the stack. Or it's called stack memory. Okay. Okay, so that's pitfall number 1. You don't want to do that. So we're trying to delete a variable, a local variable in the method, but this variable is on the stack for the methods and will automatically be deleted for you. You cannot yourself touch this region of memory. Okay, so you're allowed to ask for more memory from the heap by saying new, but you're not allowed to delete memory that you did not allocate yourself using a new. So that's a rule of thumb there. Okay, so that's one pitfall that I've seen. So people create a reference and then they'll think, oh, I have to clean it up. But no. Only if you yourself dynamically allocated it. Okay. And the other pitfall I've seen goes something like this. So let me define another method here. So let's say I did something similar where I had a method, and this method is supposed to actually return a reference to some object. So not the object, it's not going to copy the object, it's going to return a reference to the object. So I can do that. Let's say I make this object here, and then I'll return a reference to it. Okay. So then down here, let me call that, I'll say my class reference is get objects. I'm just calling that method. And let's go ahead and try to print out the result of get x1. So it's a reference, so I have to use the arrow notation. So I'll say printf. So say, I'll write exactly here what it is, object1ref, get x1, and I'll put a line break. Okay, so the question is, what will this do? I mean, it seems like, kind of following this logically, it makes an object, returns the reference, and then I use that reference, I go in and get x1. Well, that should be the first integer here. So this should print 174 at the end there. Now pause for a second and see if you can think what's going to go wrong. It's similar to the problem with pitfall 1. So my hint is this is not a dynamically allocated object. This is an object that is locally declared for this method. So let's run this and just see what happens. Okay, we're already getting a warning, actually. It let us go because it's just a warning. It's like that little yellow sign you used to get in NetBeans. But it's warning us. It says address of local variable object1 was returned. Okay, so remember I said these are local variables, local to the method. And what happens to them at the end of the method? Well, they're deleted. They get deleted from memory. So I'm returning a reference to something which is deleted. If I try to go to that address, who knows what's there? It's like somebody vacated their house. Who knows what's living there now? Okay. So let's try to run this. And it says segmentation fault. Okay. So what happened was we returned an address to a place that's been condemned. Okay. That the method deleted that memory. So it freed it up for other methods to use. And now we're trying to go there. We shouldn't be there because no other methods have used it yet. Okay, so that's a problem. Again, if you dynamically allocated this, so if I said my class object1 is equal to new my class, and then I return that directly as a reference, then this will be fine. I just have to remember, since it wasn't deleted in the object, I better delete it down here when I'm finished using it. Okay, so anytime I see a new, I should see a delete. So let me go run this. Cool, so that worked. All right, because it wasn't deleted. Okay, so those are two pitfalls I've seen, so watch out for that. Let's take a moment, meditate on that. And in the next video, I'm going to finish the linked list translation, and you'll do a little exercise on that. Okay? Let's go.